Welcome, everybody, and thank you for joining us today for this critical conversation on the future of suburbia. This webinar is part 3 of a virtual learning series on the next generation of American suburbs presented by New Cities and the Toyota Mobility Foundation. My name is Alan Berger, and I'll be presenting first today. I am Professor of Landscape and Urban Design at Massachusetts Institute of Technology, and I'm the former director of the M.I.T. Norman B. Leventhal Center for Advanced Urbanism. And I'm founding director of MIT's P-REX Lab, which is a research group focused on the broad concept of landscape sustainability in urbanism. Also joining me for this webinar are Kim Flom and Thad Rutherford. Kim Flom is Assistant City Manager for the City of McKinney, Texas, with supervisory responsibilities for the Development Services, Housing, and Community Development Departments, as well as McKinney Main Street and the McKinney Public Library System. Kim is a national certified planner and a registered landscape architect with more than 20 years working in the public and private sectors. Thad Rutherford is President and CEO of SouthStar Communities, where he oversees the company's $300 million portfolio of residential development properties. Thad will be speaking about projects we are working on together in the San Antonio area, as well as a large new master plan community in New Braunfels, Texas. The format today is going to be the three of us giving presentations. I'm going to lead off the presentations with a deeper dive into the explanation of these new software tools that I presented in part 2 of this learning series. And also I'm going to talk about how you, the viewer, will be able to access these tools in the future. Then it'll be followed by 2 of our case studies presented by Kim with the City of McKinney and Thad with SouthStar Communities. So I'm going to just start with this explanation of the tools, and you have to be a bit patient on some of these. I'm going to tell you why. It's complicated to explain software in 25 minutes, number one, but number two, there's a lot to learn. There's a lot of depth here. So try to prepare for people to be able to learn enough or take away the general basic concepts to be able to use this in the future or be interested in going to these software portals to be able to use them. But our goal in the workshop is really just to achieve a general understanding of the novelty and structure of the tools and how they're used to model for future mobility in the autonomous era. So I'm going to do this overview, and I'm going to talk about the key elements and how they're unique for urban designers and spatial planners and city agencies to use. Now, the new tools, there's 2 of them. The one is called Oasis, the other one is called Mirage. They're new, very powerful scripts that we've written for the Rhinoceros 3D software environment and also the Grasshopper software environment, which works within Rhinoceros 3D. So those of you who don't know, we call it also just Rhino, so I might refer to it as Rhino. The tools provide users with a new way to really evaluate and, most importantly, objectively measure the benefits of design trade-offs as development patterns evolve from what we do today, which you can see in the upper right-hand corner, to what we do in the autonomous mobility future, which is a new pattern of development you see depicted in the right-hand corner. But as you can see in these before and after drawings that have run through our own modeling, the tools really are used to optimize future design. And what we've been able to do is optimize for things like less paving redundancy in the future, more landscape space that functions for environmental benefits, more shade to reduce the heat island effects of excessive paving in suburban environments. We've also looked at more safe connectivity for pedestrians across various urban fabrics. We've made roads more efficient, parking, delivery infrastructures to reduce household trips within suburban environments. We've even looked at better stormwater management and potential greenhouse gas reduction, and what the value of mixed use proximity is through what we call micromobility, or essentially the last mile segment of mobility. how people can walk and pedestrian activity or e-bike or bicycle activity can be more saturated within developments and safer. Better integration of universal access and design. And also we've looked at some parameters to improve equity for lower income mobility solutions where there currently aren't very many. The exciting news and one of the big announcements here in this webinar is that thanks to our Toyota partners and those others who we've worked with, especially Toyota Mobility Foundation, who has both, funded the research we've done over the past several years, and also brought in our case study people here today, real developers and our city partners, to work with us during the process of developing the software and give critical feedback. We're able to make these tools available to the public for free through a technology licensing agreement with MIT. And we will also provide users with tutorials that will get you up and running. And I'm going to come back to this at the end of my talk and show you how we're going to sort of create the access for you and how you're going to access the material in the future. So let's dive into the tools themselves. This is our general workflow diagram. It's a lot to take in, as the next one will be as well. So I'm going to run through this. Basically, we're using parametric tools. We use Oasis, which is really at the larger scale. It's the sort of district scale or the planning scale modeling tool. And on the right-hand side, you see Mirage, which takes what we learn at the planning scale and moves it down to the block scale, a much smaller scale, to allow us to find how to optimize at that smaller scale. Users can choose to work also at either one of these scales independently if they want to. And if you're really proficient in Rhino 3D or you're proficient in Grasshopper, you can even write your own scripts. You can even add to our tool. So it is open-ended and it is user-friendly in that way. So I'd say this slide probably is the thickest slide I'm going to explain. I'll try and do it very quickly, but the general idea is, inside of Oasis, here's how we work. And you can see these are numbered 1, 2, 3, 4, 5. And we start out essentially right with zero in the workflow. It's a typical optimization process in Oasis. We begin by getting a study area from our stakeholders, a city or developer. We do research on the typologies that exist in the area. We measure them, so we have some baseline metrics, so we know how development works in the area. We identify the proposed mixes of land uses that the new master plan or the new development area is proposing. And this usually shows up as a land use plan, which you see in letter number 0 here. And then, my team likes to say this is when the fun begins. Once we receive this master plan or the land use plan, our team starts working on developing a unique scoring system for land use compatibility to design with. And we rank the values based on this big idea that in the future, land uses that may not be compatible to be next to each other today, in the future with autonomous mobility may be much more compatible to be next to each other in the future. And so it's important to rank this compatibility of adjacency. And also we assign penalty functions for, specific conditions that we put into the model. So essentially the penalty system is defined as both, something that will check an undesired adjacency, or ensuring that maybe the stakeholders have a specific thing in the plan they want to make sure that doesn't get lost in the modeling tool. So I'll explain more about that in a minute, but based on the scoring parameters and the desired land uses, the optimization model runs, in many cases, tens of thousands up to millions of desired land use permutations. That's number 3 here. We input the penalty score and adjacencies into this parametric tool, Oasis, and it runs all of these models until we tell it to stop, and it makes new configurations, and then it ranks them based on our scoring functions. And you see in number 4, it exports the top 2 or 3 ranking models. And then what we do is we look at those models, and through iterative design processes that are more familiar with urban designers and landscape architects and planners, we adjust it and visualize it through other design software, number 5. So this is kind of how it operates on the Oasis tool. Now, the land use and compatibility index and scoring sort of works. This is a diagram for you just to understand it. It's more complicated than this, but this is the general concept. On the left, you see is a simple land use plan with the typical colors, yellow for housing, green for parks, et cetera. And we essentially assign a ranking system that allows us to say, today, what are the current adjacency issues? And so, for example, in our scoring system, you would see if park is next to residential or green is next to yellow, they get a high compatibility score. So they would get a 1 score each. And ultimately, you do that for all the land use adjacencies, and that gets put into the model. And then the model calculates all of this for the overall site. And then we compare the baseline that we did with other land uses in the area to the new configurations that Oasis runs. And then Oasis does things like sort of, if you say, don't put this land use next to that land use, there's a penalty score. It won't do that. And it'll run the whole site. It'll essentially run the entire site, and it will calculate out what the adjacency should be. And it's important for you to think about this as sort of in the future autonomous development scenarios. There's going to be a lot less, think there's less parking lots with autonomous mobility. There's quieter, more predictive roadways and vehicles. There's more mixed use neighborhoods with retail services within them or commercial services within them. There's less office parks. There's more work from home, new hybrid models of work. And there's new road design for universal access. So what is not compatible today may be compatible tomorrow. And that's why we build in this ranking system. Now, this is a really fascinating element of Oasis. What we discovered after running hundreds of these modeling tools, modeling runs, these various master plans, is that the tool, Oasis, essentially continually does the same thing. It breaks down these large single land use areas, which suburbia is known for, into much smaller land use clusters. And there's a reason for that. The model based on the performance objectives is sort of optimizing for things like micromobility. It's optimizing for less car use, paving reduction, the environmental factors that we put in for optimization, more continuous landscape cover, for example, more park space in proximity to homes. So the model is atomizing these large land use pieces into smaller ones. We call this the atomization phase of the modeling, because as you can see, it breaks down essentially these large single colors into more of a confetti of these colors. Now, McKinney and SouthStar are going to explain more about this in the case study, so I'll leave it at that. The optimization in Oasis creates, again, the atomization phase, which you can see if you're a land use planner, it would basically reveal itself as a more of a mixed use neighborhood. But another really interesting detail is to understand that the atomization of these blocks happens because the model wants to essentially create more proximity for users. Okay, so what does that mean? That means that when we start to model these land uses, you see on the right-hand side on the top, that's an existing sort of single large chunk land use that you would see in today's kind of master plans. When you optimize for proximity, you go down to the bottom drawings, bottom two drawings, you see that the optimized design run through Oasis, when it goes through the atomization phase, creates an 85% increase in proximity in this particular design of green space for residential to other land uses that we're modeling for, but it also creates a 90% increase in proximity or walkability to neighborhood retail within distances of not needing to use a car for every errand. And I want to stress the importance of this as well. Sort of the conceptual idea behind a lot of this is, reduction in carbon, all the carbon mandates that cities now have. We're trying to increase, obviously, the walkability and mixed use aspect of master plans simply because the average US household makes about 1,700 trips per year only for work, shopping, and recreation, or more than 5 trips per day per household in a vehicle. So the intelligently designed autonomous situation, when it's optimized, we see through our models on the right-hand side, can reduce this in these optimized models to under about 700, about 676 on average, or about a 60% reduction in household trips. Now, this is why we need software such as this to test these new models, because the autonomous future depends on things like reducing carbon, reducing household trips, and also making sure infrastructure is not only for car-based urbanism, but also for pedestrian use and comfort and environmental factors. So I want to also point out that the great benefit for planners and designers and developers is that our tools optimize for the stakeholder objectives, obviously, but it also allows you to calculate all of the spatial metrics very easily in the output design, or to quantify the benefits of the new autonomous neighborhood design. So from road paving, for example, you see all the categories here: road paving, carbon sequestration, runoff, even more building potential, even the idea that you can add more buildings, square footage. The development metrics are in there. But as practitioners ourselves, and we think about this all the time, we see this aspect of the tool as being critical. Why? Because it can educate decision makers and create the arguments essentially to the public, to be able to talk to the public about the benefits of the future of this autonomous mobility transition. You can see the metrics. For example, the open space in this model we ran, open space increases by 93%, runoff is decreased by 76%, and you can still increase the development. In this model, we were able to increase the environmental benefits, but also we were able to add 277% more commercial square footage in this particular model. So, that's why this is really a valuable tool as well. Oasis sort of looks like this as it churns out models for us. Again, the tool generates thousands to millions of these, depending on when we turn it off. It's reconfiguring the model based on the neighborhood, or the land uses based on the specific parameters that we input. And it ranks them for us based on the penalty scores. Now, in this case, you see on the left are all the various models. This particular one ran about over 10,000 models, and I put some of them on the left. But it looks like what it's doing on the right is what it looks like. And in this model, we were only modeling for 4 optimizations. One, we wanted to maximize home distance from the larger arterials, the larger primary roads. But at the same time, we're trying to minimize distance to the secondary smaller roads, which we know will be in most of these neighborhoods. We're also looking at the same time, how to maximize contiguous green space in the residential and commercial zones, and also at the same time, maximize home adjacency to the park space. So, these are things that normally may not work together in a model. We're trying to make them work together in this, and it does work together, and it gives us the highest ranking versions. Now, I'm going to go into Mirage real quick. Mirage, again, is the block scale tool. And the Mirage takes what we learned from Oasis, and it moves us into a much smaller scale of the block. And I circled 2 key elements of the Mirage tool that make it unique. One is, we designed these sliders, these parametric sliders that we call modules in the tool set. And the modules are based on the development criteria that our clients are interested in talking to us about, the things that they need to accomplish regarding the objectives. For example, floor area ratio, or FAR, or the density of a particular development, or the setbacks that are in the building code, or the yard area required, lot size. These are all sliders, floors, building height, et cetera. We build them into the parametric tool, and the sliders allow you to see the real-time spatial layout changing on the screen along with the metrics. So this is a look under the hood. It's not very sexy. It's not as sexy as the last visual I showed you, but you'll see the slider moving around on the right-hand side, and you'll see the real-time changing. Now, we're just in this one exploring density. This is the density parameter module. It's a script we wrote. And you can see it generating new geometries on the left as we move the slider. And the sliders are based on autonomous rules that we know will happen in the future. So we build them directly into the scripts. So using Mirage, we can test a lot of specific design performance parameters quickly, and so will the user. So with the slider interface, the users can increase or decrease each parameter. It's very flexible, and the user can experience even making their own. If they're familiar with Grasshopper, they can create their own sliders, or they can adjust the sliders that are going to be in the user set that's released this fall. We anticipate having about 20 script modules to be used for different design objectives that the user will be able to get. This is a module we created that assists with placing parking, essentially land use and parking for autonomous vehicles in a hypothetical future autonomous gridded suburban development. So you see the primary road networks are laid down. And then what the tool does, it automatically determines how to distribute the autonomous parking lots, which are the circles. And the charging infrastructure for those cars is inside of each of these circles. So those are the hubs. And it does so equitably, which is really critical here, right? That we can use Euclidean geometry or Manhattan distance. Either one of those we can model for, and you see that the little lines here are in this recurring, I'm sort of looping the video for you. The lines are basically showing an equitable least wait time for each home in the development to their nearest parking lot. So, there's an equitable kind of parking situation as far as wait time goes for each of the homeowners. Our modeling shows that, pretty consistently when you have over 500 homes, these larger master plan neighborhoods, you need more parking solutions. This is a particular slide that shows 3 scales of parking. It's not going to be just, everybody parks at one big lot. And the reason is you need 3 of these is because in the future with autonomous mobility, autonomous suburban neighborhoods, most likely driveways are going to go away and garages are going to go away at each house, which are, if you look at the scale of 500 homes, extremely wasteful and redundant. So if you can get your car in 30 seconds or a minute, you're gonna end up seeing these kind of variety of parking situations. So, the parking situation will vary depending on different users, trip length, vehicle right sizing, what each user needs. So for example, somebody that has a disability will need a different kind of vehicle than somebody that doesn't, and you can call those vehicles up. And what you're seeing here isn't necessarily, coming out of the model. What we do is we take the Rhino 3D model, and then we use visualization software, which I'll show you in a minute, which all urban designers are familiar with, and we render the scenes out from the base Rhino model, what the Rhino model is giving us. So for example, this is a before and after. We do a lot of before and afters for the people we work with to use as communication tools and to educate the public. This is a before and after of a large suburban parking lot. And as you all know, who have ever parked in one of these, they're typically pretty uncomfortable for people. And they're certainly not the greatest environments for ecosystem services either. In the future, what our model is telling us is in this sort of larger parking lot space, they are going to be designed for autonomy in a way that saves about 40% of the space because of automation, because essentially doors don't need to be opened when you have an autonomous parking lot. So in this case, shuttle buses, they can park closer together. That releases 40% of the typical space of a large parking lot for other development uses, for example, for community uses, for environmental purposes, for landscape functions, or even for shade canopy to mitigate the heat island effect of these parking lots. This is a medium scale lot. You see this a lot in suburban environments, in smaller office, commercial areas, and even multifamily housing zones that are spread throughout, pretty ubiquitous in suburban areas. They have similar shortcomings to pedestrian safety and comfort, but they also take up a lot of space simply due to old building code that hasn't been updated and needs to be updated for future mobility. So we believe that the tools that we've created can help agencies actually revise code for this autonomous transition by returning much of the space to the community for landscape uses, simply because there's going to be more ride sharing And also there'll be mobility on demand options and lots of micro mobility options as well. So in the future, a typical medium scale lot might look something like this. Rather than just being a parking lot and a single use, these medium scale lots, which can be spread throughout developments, can become community hubs or places of intermodal connectivity. Here you see parking is co-located with community activities, gathering spaces, convenient retail, smart lockers, outdoor market space, even a multimodal mobility charging station. And they'll be designed to be universal access, curbless pickup and drop off, and what we call universal and ageless access design. This is what, I showed you these images. They're beautiful images. They're renderings we use to communicate. This is how we make them. Just to recap this so you understand, the raw Grasshopper outputs are modeled in Rhino 3D, right? And then the designer takes it. The designers who are on the team take those layers and they build representative, more photorealistic representations of the modeling scenarios in rendering software. We use a rendering software called Lumion, Lumion, and the reason is because Lumion allows you not only to build this kind of texture and this kind of imagery, but it also allows you to get inside of it and create walkthroughs. And those are really helpful to communicate with your constituents. So, for example, this is another example of a typical suburban residential 4-lane street. And when we run it through Lumion and do everything in the modeling, this is one of the final designs. You're able to use this to communicate with your constituents on all the various new infrastructures that are going to be on streets, right? It's not just about cars anymore. It's going to be about all kinds of vehicles that are moving around doing different kinds of activities. It's also going to be about micromobility and charging and communal space, place to meet each other where these things are happening. So they're really useful communication tools. And this is just a short movie of some of the things that we're able to do in Lumion. This one in particular is about drone dispatch and delivery. And you can see the dispatch sends the drone out from within the neighborhood. I'll talk more about that in a minute. Homes will probably be designed to receive these packages. There'll even be a kind of storefront delivery where the robots will be able to deliver to the home autonomously in their own lanes or shared micromobility lanes. People with disabilities will have their own access points, and there'll be safe pass-throughs simply because pedestrians get the priority in these environments, and it'll be a safer environment as well. Now, this is really interesting. I just threw this in because we're here, and I just want to show you the power of the tool. So, on the left is a typical, package delivery. I'm showing this simply because, we have so much more package delivery to homes now. We all shop on the internet. But in the future, drones and package delivery systems are being really innovated to do different things. And we have to think about how they're going to be integrated in the neighborhoods in the future. So you can see on the left, basically the redundancy, the inefficiency of how we get packages now, right? They come from a single warehouse to the home, and a truck has to essentially drive along all of the neighborhood streets and go to every single home to drop off a package. Well, on the right, you see a future scenario. It's a decentralized system where the autonomous trucks essentially get dispatched from the warehouse, and they go and they enter into the neighborhoods, and they essentially have hubs within the neighborhoods. And from those hubs, you have a secondary system of drone delivery. So what's the takeaway from this optimized version of this neighborhood is much less traffic, much less truck traffic on streets and neighborhoods, and a great benefit to people who are interested in micromobility or recreation or more community space, safer neighborhoods. In the next 5 years, this is probably already happening right now, but it certainly will happen in the next 5 years. This is the delivery routing module we made. And this is in the Mirage suite. And you can see that, when you apply the sliders here, which are doing various functions on the geometry, you get on the left, you see, right, the housing is yellow and the green is open space. And then one solution that this particular model is looking at finds the most efficient routes for delivery bots. So in this study, we program the routes to avoid passing through any of the park space. They have their own lanes. They never go through park space. They never interrupt that kind of activity. And we did that by adding a penalty function, and the purple lines essentially show you, the optimized delivery routing. And this is something you'll be able to access if you're interested in this. We've also gone as far as package distribution, and we created a model here. The purple lines are the primary delivery the delivery bot hub routes, which I showed you in the previous slide. The circles are their hubs, or where they wait before delivery, and the lines show which homes they deliver to. Again, the cool part about the tool is that it's all adjustable. So the designer can work with the planning agency to create greater or fewer stops based on the housing density that will be in the development, and then can visualize the pathways of package deliveries using the slider function in Mirage. Okay, so I'm going to wrap it up by just talking about how you'll be able to access these tools. Thanks to MIT's Technology Licensing Office, we've been able to organize everything for users on a new MIT website for accessing the tutorials and the scripts. This will be up and running this fall, sometime in November. The website is going to have tutorials to help you load all of the software you're going to need onto your own machines. It's going to show you how to download the scripts that we've written for the Grasshopper modules from the MIT server space. And it's also going to help you prepare to run your own optimization schemes and create your own simulations. After the website goes live this fall, users will go to this URL. Essentially, what you're going to have to do is follow the instructions and email us at MIT. We're then going to send you a link to MIT's user agreement. After you sign the user agreement, you will get access to download the Grasshopper modules and all of the tutorials that cover creating land use maps, optimizing land use distribution, as well as the block level configuration of all of the things that we described here today in Mirage. The website is going to also provide 5 case studies that we've run of these different modules being applied to different sites. It's also going to have the metric results and visualizations from those case studies. So we hope to illustrate how we're able to use these in real time, but also the potential of performance increases that are possible through optimizing neighborhood design using our tools at the planning scale and at the block scale. Now, we strongly advise, once again, that users who are interested in downloading this and getting into the tools this fall, that you become proficient in Rhino 3D, the Rhinoceros 3D, and Grasshopper. And if you're not, you have an urban designer on your team. If you're a planning agency, for example, or an office, that you have someone on your team who knows how to use these tools and works in your group. This is because the team still needs to be able to get together to decide the inputs and objectives, or essentially create the adjacency scores and penalties for any particular project. Now, I would argue that's an extra step that you have to take, but at the same time, that's the great benefit of this tool. It's an excellent collaboration tool if it's used this way. And if you need help, you can always reach out to us for any kind of collaborative assistance. So in summing it up, we anticipate the final website to include the software modules and the scripts allowing users to explore autonomous suburban design through all of these modules that we've worked on: land use compatibility, quantification, green space allocation, including accessibility and continuity. Continuity. I think that's spelled wrong. Specific land use distributions and amenities, and how we can automate where amenities are placed more equitably through developments, autonomous vehicle routing optimization, drone delivery routing, mobility corridors, and even developing the network of mobility corridors and how they can be optimized for equity, block structure generation, and importantly, it's also connectivity ratio calculation, how to create new kinds of intersections and new kinds of road optimizations instead of using old patterns that building codes just simply haven't updated. And also for developers be interested in floor area ratio optimization. So there's many more. We hope to have about 20 of these modules. And I'll just leave you with this slide. And then I'm going to pass off to Kim. This is an actual optimized neighborhood design we worked on with these guys. And, it shows you the full scope of the development. It doesn't look like a typical development. It's a mixed use, autonomous suburb of the future with micromobility hubs, drone delivery ports, drone delivery hubs, lots of micromobility routing, significantly reducing household trips and the need for household trips. And all kinds of fun things in here. So these are the kinds of elements and kinds of plans that you can look forward to modeling in the future once the tools are made available this fall. So I didn't say thank you. I look forward to working with anyone who's interested in using the tools once we go live. And now I'm going to pass this off to Kim Flom from the city of McKinney. And Kim is going to walk through some case studies and give you also a debrief of things they're doing in McKinney. Thank you.
Thank you, Alan. Happy to be here to talk about the city of McKinney's experience with the Toyota Mobility Foundation and MIT on this exciting project. You go to the next slide, Alan. Before I dive into our two case studies, I want to talk a little bit about McKinney, set the stage, if you will. We are a fast-growing community located in the Dallas-Fort Worth Metroplex. As of the most recent census, we're at 206,000 people. We share fastest growing with several of our neighbors, and it's something that we're very proud of and something that we're excited about, and one of the reasons why this tool is so important to us. Next slide, please. We are primarily a suburban style community of Dallas. We're filled with neighborhoods of varying character, but there are several things that distinguish us from our neighbors. We do have a historic downtown. McKinney was founded in 1848, currently serves as the county seat for Collin County. We have several beautiful historic buildings. We've had historic industrial areas in our community. We also have an airport and a very large business and industrial district around that airport. All of that makes us a little different than our neighbors. Most of our growth over the past 20 years, however, has been kind of suburban in nature, although we do have several different styles of residential neighborhoods with a wide variety of housing products. Next slide, please. I'll walk through a little bit about what we look like in map form and how we've grown over time. So this map shows the developed and undeveloped areas of McKinney. At full build out, we anticipate to be about 115 square miles. Everything that is in color here is our currently developed area, and then the light cream area is undeveloped. So as you can see, we're right around at this time, right around 50-50, maybe 55% developed. We have about 54,000 single family homes and 20,000 multifamily homes. If you can click on the next slide, Alan, we'll walk through where the growth occurs. So here's our historic downtown. This is where it was originally located. Once that was developed, you go to the next slide. Some of the business areas around the downtown grew. And then if you can go to the next slide, Alan. Most of our growth in the residential area really occurred between 1970 and 2010 through a variety of neighborhoods in this quadrant of the city. Next slide. Our future growth areas are really in the north, northwest, and northeast areas. Next slide. Our comprehensive plan is our driver for how we grow, and that's going to become evident as especially we go through the Oasis model. Our comp plan vision requires that we believe that smart public and private investments will ensure that McKinney remains a top choice for residents and businesses in the future. We aim to create places of lasting value. Next slide. In 2010, we were lucky to connect with the Toyota Mobility Foundation and the great MIT team that they put together. And essentially, they pitched us kind of a local government dream project. They said, hey, we are looking to build a tool that's going to model and plan for suburban growth in response to autonomous vehicles. It'll be data-driven, it will have visual graphics, and all we need to do is to partner with you so we can use McKinney as a model. It really doesn't get any better than that for anyone in the local government world, and we were really happy to work with them. It also aligns with our vision at the City of McKinney. We really believe that we build relationships. That is what we do every day, whether it's within our community or external to our community. So it was really a blessing to be able to work with the Toyota Mobility Foundation on this one. With that, I'm going to go into two case studies, one that features the Oasis model and the other that features Mirage. Next slide, Alan. So as Alan mentioned, the Oasis model is really district or regional focused. This is an image that shows a section of McKinney as it currently exists today. And you can see the photo reality of some of the slides that Alan also showed. You have the commercial center on the corner, and then you have varying levels of residential and open space in the back, but they're all lumped together. Next slide, please. The Oasis model is really powerful for us because it reminds us how autonomous vehicles are going to change the way our land uses are optimized. Alan mentioned this, but we're going to be moving from these centralized land uses that are in big chunks to a more granular distributed land use pattern. That's not what exists today, but it is what will exist tomorrow, but it is going to happen over time. So even just this graphic, and if you can click to the next slide, Alan, in contrast to this one, shows that difference. This graphic alone is a powerful tool for us in local government. Our primary role when it comes to the built environment is we shape it through our comprehensive plan and our zoning regulations, but we also communicate it with our residents. So we aren't drawing the plans necessarily. We are laying the groundwork, and then developers come to us with those plans. The way that the Oasis model was built, that included the scoring system based on values and adjacencies, was very powerful. Even today, when we have our land use blocks, I mean, that's what it's all about. That's what our folks who come out to planning and zoning cases, who don't like things in our backyard, they're giving us those scoring systems. Now, in a future world where we don't have the large trucks and the traffic and the roads, things are going to look much different. It provides a lot more opportunity, but it's also hard sometimes, especially our citizens and our business owners, to understand and contemplate that change. The Oasis model itself gives us an incredible tool to help communicate that and communicate the benefits of more distributed and more granular land uses. You can go to the next slide, Alan. We loved the imagery that was provided as part of this project because not everyone can read maps. We learned that very quickly in local government world when we're sharing development projects with everyone. So these images that show the increased landscaping, the pedestrian mobility, and the data behind it, noting that in a future world with more distributed land uses, 85%, if that's what you set up in the model, of all households are within a half mile of public amenities, this can be a reality, and this model shows us how that can happen. Next slide, Alan. So next, I want to talk about a suburban office retrofit project. I mentioned before, McKinney is about 50-50 built out. The Oasis model is an extremely powerful tool for us to look at our greenfield areas, our areas that are not developed. And it's also a tool that aligns with the comprehensive plan level planning, where we're looking at broad areas of how things can grow and what it might look like in the future at a large scale. The Mirage helps us dive into that a little deeper. Mirage is a little bit like our development regulations. It's our zoning, it's the regulatory documents between what things look like on the ground. Alan mentioned the FAR and the setbacks and the landscaping. Those are all things that are in the Mirage model. So there were a couple of reasons why the suburban office park model was extremely relevant for us right now. One, as we know, with the COVID-19 pandemic, the way people worked drastically changed. And while there are still several people working in the office, this is a long-term permanent change. With more people working remote, even without autonomous vehicles being predominantly on the road, we're seeing a change in how people work and where they work. Additionally, we're also seeing a change in the development world as related to the land uses we talked a little bit about before. We really aren't seeing these large office complexes being proposed anymore. What we see more in McKinney are what we'll call horizontal mixed use developments, where you might have an office tower, but next door is sort of an entertainment, pedestrian focused area. And then there might be a hotel, and then there might be apartments. And it's all within sort of one pod. So knowing that these things are already happening in the development world, this model in particular about what could happen in the future is very relevant. Next slide, please. So one of the great things with the Mirage model is that it showed a range in the spectrum. So it didn't just say, here's where we're at today, and here's where we'll be tomorrow when we are 100% autonomous vehicles, but it actually showed a range of how that could change over time. This is extremely powerful for us because knowing that it's not an overnight thing, likely we will be dealing with this in incremental steps over several years. And in this version in particular, we can see how different components of this model could be integrated into our development regulations over time. Next slide, please. And this is one of my favorite renderings of the entire project. This is a before picture of a suburban office parking lot that we're all probably very familiar with. Next slide. And then what that could be in the future, when that parking is no longer needed, the space could be infilled with well-scaled, well-designed buildings and a lot of pedestrian amenities around it. Next slide. Other than just using the model for our comprehensive plan and our development regulatory efforts, there are a lot of opportunities for municipal planning with this project. Development review, I kind of already talked about. We can use these models on either scale to take a look at projects that are brought to us from developers, to analyze them and provide our decision makers with data behind it to help them understand whether the project is fulfilling the comprehensive plan goals as well as the policies set by our elected officials. Capital improvements project is another great opportunity here for municipal planners. We currently manage over 100 projects a year that are valued anywhere between $300 and $600 million in McKinney. These are roads, these are utilities, sidewalks, parks, municipal buildings. This kind of tool over time, as we move into a more autonomous vehicle environment, can really help us be strategic about where we're investing those dollars to make sure we're putting the right infrastructure in place to take advantage of autonomous vehicles rather than being stuck in kind of what we've always done. Education, I can't emphasize this one enough. A lot of what we do is communicate to our residents, businesses, and all of our external stakeholders. So these tools not only have the data behind it and the flexibility to adapt to our policies and objectives and growth patterns, but they have the imagery that helps us share that story and explain it to the general public. And then finally, the analysis. Alan went into great detail about how you can adjust certain parameters in each model and how that changes the model for an optimized land use pattern. This is incredibly powerful for us as council sets goals over time, as we move into a world with more autonomous vehicles, and our elected officials say, you know what, for the next 10 years, this is a priority for us to grow in this manner. We can see using this tool to adapt that data input to make sure that we're achieving the goals that they need. Overall, we were just really excited and thankful to be a partner on this project and are really looking forward to sharing the news on this model and also using it in our efforts in the future. Thank you, Alan.
Kim, thank you. That was a very informative presentation and a very good recap of the work that we've done with you. And a great reminder to us and our team about how useful these tools can be in the real world. Next up is going to be Thad Rutherford again. Thad is the president and CEO of SouthStar Communities. And we've been working with Thad on a couple of projects in the Texas area, one in San Antonio, as well as a large master plan in New Braunfels, Texas. And again, Thad, just let me know when to forward the slides here.
First, I want to also thank Kim and the McKinney presentation. That was fascinating to kind of see the use of these models on the other side of the proverbial table. And I also love the case studies that she presented. My name's Rutherford. I'm president, CEO of SouthStar Communities, and happy to be here today and talk about two exciting communities that we are planning, designing, and constructing with the great use of Oasis and Mirage. So next slide. So I think I always tell a story of SouthStar. We're kind of a traditional residential neighborhood developer, but you would think that's not the type of developer that would be as interested in using some of these models. But I think we're a great case study of really evolution of a developer and how we think about planning our communities that we love and want to be successful. So again, traditional mixed use planned communities are what we've done for the last almost 25 years. Most of them are large scale. Most have a kind of heavy emphasis on residential, but what we've seen the last 10 years is most of the projects that we're planning have to have a component, non-residential component, whether it's retail, commercial, institutional, educational, or other uses. So we had to kind of think differently rather than just laying out a residential perspective. We're a long hold developer, so we're not investors, we're community builders, and the average length of us being involved in the communities that we're working in are at least 10 years. So that's important. We built great relationships with our stakeholders, like our municipalities and our other partners, including our residents, and we learn a lot from all of them. So I think that's part of this process that we've gone through and been lucky enough to go through with Alan, his team, and the Toyota Mobility group, is things that we are eventually going to be able to share with our residents, which is exciting. Next slide. So it's just kind of our footprint. We're primarily focused in Texas, but also have been throughout the state of Florida, a little bit in North Carolina and Georgia. Again, most of these in the last 25 years have been anchored by residential, but like I said, just the last 10 years, we've kind of thought a little bit differently when it comes to creating these communities, which they turn out to be smaller towns. So they need a diversification. Connectivity comes up more and more when we have that different uses playing back and forth. Next slide. So again, we were lucky, like Kim, to be introduced to the M.I.T team and these powerful models from the Toyota Mobility Group Foundation Group. Very, very happy to have been introduced. We were also brought in by Texas A&M San Antonio, who's a partner with us on our project in South San Antonio, and excited to talk about two case studies that we're continuing to use the models even as we speak. And I think that's an exciting, we can kind of talk about some of the things that we've done already and that we're working on, and then some of the things that we're continuing to analyze and look at. And overall, I would say that these programs, these models are making us be better community builders. And I think that's exciting. I don't know if I originally felt in the beginning that's where we were going to end or so strongly. So very excited. Next slide. So this is kind of the end result. So this is what we see our Vita project in San Antonio looking like, let's say 12 years from now, 15 years from now. So I wanted to kind of go to the end and then kind of reverse backwards to see how we got there. But this is our project, our mixed use project in South San Antonio. It's adjacent to Texas A&M San Antonio, a 7,000 student satellite campus of Texas A&M. And we're also flanked on the other side of this highway by Palo Alto Community College, which is an award-winning community college. So we've got a lot of uses around us that are kind of playing in and out of our community. Next slide. So Vita is 600 acres. Like I said, it's adjacent to another 600 acres of Texas A&M San Antonio. At full build out, it'll be roughly around 4,000 residential units of a variety of mixed, single family, detached, attached, multifamily, more traditional garden, some higher density mixed use residential. We also have a 65 acre University Health System, which is the Bexar County's health system provider. They're going to have a healthcare campus with a brand new 200-bed hospital down there in the bottom left of the master plan or the rendered plan. We're also going to create a town center focused around what we call the Zocalo. It's somewhat similar to what Kim was talking about, that horizontal mixed use areas are kind of the future of where office and another retail want to be located. And we're excited to kind of create this Zocalo space down at the bottom, which is directly adjacent to Texas A&M, which we want to be walkable. And I think that's the thing that really drove us to diving into this experience with Alan and both Oasis and Mirage, was to kind of take everything that we were trying to do as, you know, land developers, as planned community developers, and really analyze it at a very kind of granular level, and then and kind of see what the program was going to spit back out. And, you know, I have to admit, in the beginning, we were a little nervous. I was a little nervous. You know, we had an idea of what we wanted VITA to be. This is a lower income area of South San Antonio. It's been a little bit of underserved, underinvested, but the stakeholders down here were very powerful, very influential politically. And we just saw a lot of what we wanted VITA to be. And we felt like that's a great vision. It fits with the area. But now we were going to work with this group, this M.I.T group, and these programs that were fascinating to us. So there was some hesitancy, but I will tell you, and you'll see as we go, next slide, Alan, thank you. We really kind of got comfortable very quickly. So this is just a very similar to what Alan was presenting. And I'm going to try not to butcher it, Alan, because this is your world, but we love that we get to live in it for a period of time. And it really helps us be better at who we are. So again, to the far left, the traditional land use. And this is actually a block or a use of Oasis for VITA. And then as we go and we atomize, then we optimize, you can see the uses changed a little bit. We kind of scattered some things around within the land plan. And it also gave some, it made us feel like we were making some right decisions. So it moved us into some different directions, but it also kind of solidified some of our thinking with some of our uses, some of our commercial, the scale of the commercial too. And then the segmentation of the residential was massive for us, and creating not just detached single family housing subdivisions, but more of a community base. But all of that was just the beginning for us. So we were very excited about the outcome. Next slide. So the other thing we did was look at from a Mirage standpoint, was look at an actual block. And I think the thing that fascinated our team, who we have planners on our development team, and what we really dove into was the idea of these key criteria. And it was us talking to the program about what we were trying to achieve, what were the goals. That felt like it was a little more, we were in control in a sense of trying to optimize, but not optimize for something that was a goal that we weren't kind of directly aligned with. And that there's a lot of confidence in that in talking to the team early on. So creating those inputs and those objectives was key. One of them was density, creating the right type of density, but also trying to get away from the same design structure that we've been doing this for 50 or 60 years throughout kind of suburban America. Next slide. And so this is what the outcome was. This was the AD1. And as Kim, I'll echo a lot of what Kim said. The idea of 81 and 82, if we didn't have 81 and rolled straight into kind of what the future of suburban neighborhoods would look like 40 years from now, I think that would have made us, pause a little to try to understand how to get there. And I think that's what, for us as a land developer, we needed that in between, that transitional space. And this was kind of the 81 version of a single family residential block. And these are all detached homes, but we still got, a minimum of 6 units per acre. Sometimes we could get 7 to 8. And it created what we thought was a much more interesting and exciting pattern, not just for us as developers, but what we did was we brought in our engineers to really understand how we could build these blocks. from a drainage perspective, from a utility perspective. And I think that was an exciting period of bringing these groups in. So we weren't kind of analyzing this in a vacuum. And then the other thing that was just amazing was sitting down with our builders and actually getting them to understand what we were trying to look at, trying to build, and for them to understand how their product would fit within that. So that all kind of trickles down to the consumer, the customer, which was important for us. But you can see it just created more central public space, less parking, but more strategically located parking, and then also had that future proofing for the autonomous vehicles, drop off, pickup, micro transit corridor, which we were already creating trails. But this is just one step further in thinking about how these trails are designed within these uses to make them much more usable than just a trail on the side of a bunch of residential houses. Next slide, Al. This is a view, another kind of rendered view of Vida. And you can see the highway to the north, Texas A&M campus to the south, the Zocalo down at the bottom, and kind of that scattered neighborhood commercial. That was probably the biggest move that the M.I.T. and the program Oasis and Mirage kind of moved us away, or moved us to, is not just segmentation, but moving the open space areas around and then creating some neighborhood commercial where we originally weren't thinking it would go. And then you can see also the micro mobility hubs, which we are actively working on design of some of our first micro mobility hubs, kind of that last mile transit to get home or get to work. And really happy with kind of this result. This is another good rendering that we show to the city of San Antonio, to our stakeholders, and they absorb it relatively quickly. Next slide, please. A very similar slide to what Alan presented earlier. Again, proximity analysis. We always talk about walk scores in our world of development. This was a little different. This was kind of proximity analysis isn't just kind of can you walk to one thing, but how you can walk from your home to a few different things and then scoring it. And so this was again another thing that we internally are using on another case that we'll talk in a second. It's very helpful for us. And we do this, we're now doing this very early on rather than design something and then put it into the model to see if it actually works. Next slide. This is kind of a final version of Vida. You can see we got a large right of way down the middle, but it connects back down to the town center, the Zocalo. But we've created, a lot more understanding of the different uses and how they affect each other, and then the kind of the mobility infrastructure around those uses. I think as developers, we think about all of these things, but not in the same time or in the construct of analyzing what one affects the other. We always talk about connectivity, but do we talk about connectivity and how multiple residential kind of housing products act next to open space next to our town center? And then how are we going to get people around rather than just the roads? So I think, again, the model really forced us to think about things almost in a layered approach. And once we started seeing some of the results, we got comfortable very quickly, and it also spurred more ideas for us as community builders, which is always exciting. Next slide. So this is the other case study. This is in New Braunfels, Texas. This is along San Antonio, Austin, I-35 corridor, which is, I guess, dubbed now the Innovation Corridor because of its massive growth and job creation. And so very excited about this project. It's very large scale. We have 2 brand new interchanges off of I-35 that we're working in, and we knew that we have a high speed, higher density type commercial frontage. But what we wanted to do with Mirage and Oasis was really kind of look at the connectivity in this. A lot of these roads you see on this map, this original map, are all in the roadway plan for New Braunfels, all part of their comprehensive plan. So one of the things we had to do is we had to fit within the construct of those alignments of the roads. But I think what Oasis has done for us is to kind of look at, even if we know the road has to go there, what type of road should it be? And I think that's kind of an important continuing evolution of how we land plan, and then how we talk to the cities. And I think Kim spoke very eloquently about, comprehensive plans are so critical to everybody understand kind of the planning parameters. What's the landscape? What are we all trying to achieve? How's it going to better the region? And for us, Mayfair followed very closely with New Braunfels' Envision plan. And you can see this is a 2,000 acre scale, so it's very large for a planned community along the highway. This will have 6,000 units. So I think it's kind of a little more complicated from the standpoint of trying to understand how do we get people in and out of very high density mixed use commercial corridors back to lower density or medium density residential. And this has a ton of open space. So the idea of trying to get people in and around in the open space is critically important. Next slide, Alan. So this is just the first step of Mayfair. So we're just kind of beginning the case, the use case of Mayfair. And this is kind of a look at 81 and 82. And again, we're kind of trying to go from the existing down to 81. And you can see how it kind of reduces the roadway pavement, not just increase the off-street use, but really more efficiently design it. And I think that's what we were kind of coming to, or have come to at Mayfair, is to design a more efficient pattern of micromobility or mobility choices or avenues or infrastructure kind of alignments, and not just create a bunch of trails and a bunch of sidewalks, but to really look at this from a regional perspective through Oasis, and sit down with the city and look at their existing kind of cross-section codes for some of these arterial and collector roads, and work with them. And that's been exciting, and to see the receptiveness, and obviously watching what McKinney's doing, it's very exciting to see these programs, not just from a private developer standpoint, but to see them out in the world being used by planning staff at cities and towns at a state level is extremely exciting. Very lucky to have been introduced to the Toyota Mobility Foundation and the M.I.T group. And I think we've come totally all the way full circle, and are now hounding Alan's team to get more and to do more, and to get more granular in some areas. So we haven't hit kind of a wall per se with a project like Vita or Mayfair. We continue to kind of refine and try to be better community builders, because that follows in line with, again, what some of these cities are needing. So as a private developer, I couldn't recommend enough the use of Oasis and Mirage, and I hope the private sector embraces it like we have. So I appreciate the time, Alan, and very, very excited to see the future of both of these models.
Great presentation. Really good to see the work presented through both of your perspectives. I just wanted to also say, in addition to thank you for your time here today for the webinar, it's really been a great pleasure for me and my team to work with both of your teams. I mean, viewers don't realize this. There's many people behind us that are also involved. And I want to thank my team, and I want to thank your teams in particular, and especially the Toyota Mobility Foundation team, who has really provided us with time and resources to work together. Anyone that's worked in a city agency knows that time and resources are really critical to be able to collaborate outside of the normal operations. And when you're building a new city for 50,000 homes, it's the same issue. And, TMF has really provided us with a great way to work together. And thank you for taking, it's funny, I heard you say, Thad, in your presentation, that you guys were nervous coming into the project. I can tell you, and, this goes for both projects and our relationships. My team was also nervous. We didn't know what to expect. And the main reason why this all worked out, in my opinion, is that everyone's so easy to work with and everyone's open to innovation. And Toyota makes it very easy as the liaison and funder and helper of the coordination. But I would also say there's a big risk in innovation, particularly for, the two of you, one in the private sector, one in the public sector, there's a big risk. And it's projects like these that are funded by foundations that allow those risks to happen. And I think we're all three of our teams, speaking for both of you, are all better off for this. And I think hopefully in the future, we're going to build better environments for people because of this relationship. So thank you once again. And although they're not on the screen with us, thank you to the Toyota Mobility Foundation folks who we work with every day and make this happen. So to our audience, I want to thank you for tuning in today. Be sure to check out the first part of the series on connecting suburbia, which is a conversation between the urban geographer Joel Kotkin and planner June Williamson on New Cities 360 City podcast. And the second part of the series, which is a roundtable discussion on the future of suburbia between myself, Luis Torres of the Dallas Federal Reserve Bank, and Joel Kotkin. Thank you.